the Jupyter the Jupyter notebooks in the project's upwelling folder. This is from the NASA Cloud Hack Week. So the first one is showing basically how to connect to Earth data, how to set up the net RC, and then it's showing how to find the URLs. And basically I'm going onto Earth data and kind of trying to find the name of the data. I had to do a bit of guessing there. But once I have that, then this code here allows me to search that and find all the data that look like that. And then the next one is showing how to get some data using the URL, giving it a bounding box, giving it a temporal range. Down here is showing how to get direct access. And so I'm not actually downloading a file onto my computer. I'm accessing the data in the cloud and loading the data. I am loading the data though. I'm loading a raster. So if it's really big, I'm loading in a lot of data. Okay, which I am. I'm loading in a lot of data. Okay. So the next one is this one here. So this one is showing how to get the SST at a particular lat long value. So I'm reading in some pairs of data, and then this is the code to get the data set, which is what I loaded up in the previous, and this one here is what I loaded up here. So I'm loading up this raster, and within that raster, there's something called analyzed SST that is actually in the data set. That's one of the columns. Okay, so if you're loading in a different raster, it's going to have different column names. Okay, and then I'm giving it the lat and the lon values, and I want to choose the nearest lat long centroids for this raster. So it's a raster, so it's like points that are separated, in this case by, I believe, 0.25 degrees. Okay, so this is going through how you could get the SST for all the lat-lon pairs and then make a plot from that. Okay, so this next one is just showing how to do some plotting using here HVplot. So plotting out a raster that is not area conserving, so you reproject it onto something else that is a little more area conserving. So you can reproject it here, which is an example of that. Okay, and some various plotting of points, adding points to a plot, that sort of thing. Okay, the next one is showing how you can get an average around a point. So what I was doing before, I was getting one SST for the nearest raster box centroid to that lat long value. And you might think, well, it'd make more sense to just take the average. And this shows an example of how to do that by creating these circle polygons and using some GeoPandas functions. The problem with this is that this works fine. It's just super slow. So here, you can kind of see, hopefully, that this looks kind of like a circle here. So it's taking the average over all this. And this shows you how you can do that. But in my case, it would take 90 seconds per raster. And that would be like 11 days just to take averages around a whole bunch of, for all the points that I need to. So that would be kind of slow. That's why I didn't do it that way. The next one is showing I don't think I needed actually all these packages there. This is reading in some data. And yeah, so this is all doing it in the cloud. So this is getting access with S3. And then I'm doing the SST differential on that file. So I'm working on, each file one at a time. And you can see this example here. So I did, what is that? 1, 2, 3, 4, 5 years. 5 years. And each year took about, I don't think that's the full time. I think it was taking about 5 minutes per year. Yeah, there you go. So this file is where I got the basics of how I wanted to create these plots. In the other video I show, I'm doing it with Dask. It's a little bit cleaner implementation, but it's exactly this idea here. So this next one, 6, this is a workflow where I tried downloading files and then opening as an X-ray. I thought this would be a faster way to do things, and it was. However, just doing 1 year was a massive amounts of data, and finally I calculated it and be like 30 terabytes if I downloaded all the data. So I decided that was not the way to go. Okay. So, and then the next file, this number 7, this is where I worked out the way I ended up doing it in the video I showed. And this is a Dask workflow, so I do everything in the cloud. And also the kind of the syntax for the Dask was easier. It was a bit cleaner. So you can see I can just like create these cubes of the data that I need using these, concat functions. It didn't really save time, but it was a lot cleaner and easier to understand for me. Okay, and I get to the same place here. Okay, so this one, the 7 notebook and the 6 notebook are the same. Just one of them is using Dask and the other one's downloading. And then the last notebook, this one here, is where I put it all together and download all the data. I access all the data with Dask and I create the 1981 to 2020 plots.